Now let's move on to this example over here. This is a very simple truss. We have loaded it with about 1800 kilonewtons in the middle. And the only novel thing about it is that instead of doing a normal classical linear analysis, what we want to do is do a nonlinear analysis in which the material is bilinear. So the material has a stiffness up to a certain point, and then it softens up and goes sideways. And obviously, when it crosses that limit, it crosses that yield point, if you will, then the deflections will start to grow rapidly because it will be a much softer material. And what we've done for that is we've assigned to it a material called steel bilinear, and you can define these materials in Comosys separately. So it's over here, and you can define their yield strains and their hardening factors, etc. And once you have and you can define it to be a uniaxial material or with the type of bilinear. And once you do that, you can assign that to truss members, for example. And once you have that, then you can run the analysis and find out about the results. Now, in this case, what I've done is if I go to this create edit analysis cases, I've created a nonlinear static case, and I've told it to divide it into 10 steps. So the load of 1800 kilonewtons will be applied in 10 intermediate steps according to these settings. And when we do that, let's say if I went into this, if I selected this joint and I went to my element output tables over here, I can select the joint frame output. And here, if I select the analysis case to be the nonlinear one, which I just did, now immediately it will show you the result at the end of the analysis. So it is showing you a certain number for the vertical, but what you need is the entire history. So if you select this one, which says response history, it will then give you the results at each of the 10 steps. So so this load of 1800 was divided into 10 parts. So it went from, so this is the result of 180 kilonewtons. Then this is 360, and this you keep adding 180 every single time. So if I plot that curve, and I say I want to plot the displacements of the selected node, and I want to say the U3 displacement, which is the vertical one, and I say OK, you can see on the screen that it went linearly all the way to about half the load, so about 900 kilonewtons. It went linearly, but then it started softening, and it kept the softening kept on increasing as well. And at the full load, had we done a normal linear analysis, it would have been something like maybe something like about 50 millimeters, about 5 centimeters the deflection would have been. But with the full nonlinear analysis, we see that the truss actually goes all the way to about 20 centimeters because it really softens up after that.